Alright, welcome to Unit 3.6, Equations as Functions. Okay, you're going to hear the word functions a lot in your higher level math classes, but they're not really that complicated. They sound complicated, they look complicated, but they're really simple. And I'm going to try to make them as simple as possible so you can see what I'm talking about. Alright, functions can also be represented by an equation or a rule. It's just the rule. Remember our functions video where we talked about the gumball machine. It's just the rule. You put a quarter in, a gumball comes out. That's the rule. That's the equation. That's its function. Right? The equation will generate ordered pairs by taking an input, right? That's our x, that results in a certain output. Remember, input, output. Outputs are y. So a function is just what happens between the x and the y. If I put it in x, what happens? What do I get out? Right? The function is what happens. The graph of an equation is the set of all its ordered pairs. If you graph all of the what happens, then it shows you a pattern, right? Which often forms a line or curve, right? So that you can see the pattern. Our job is to input different things into the function and see what comes out. And then when we know what comes out, we can graph it. All right, let me show you what I mean. Suppose you have the basic function x plus 5. But we don't know what it equals, so let's call that y. We can't use the x again, we're already using x. What if I say x equals 3? Well, that means I'm going to substitute the x for 3, and y is going to be 8. So when x is 3, y is 8. That's an ordered pair, right? So what if I said x equals 6? It's going to be 6 plus 5 equals 11, which means that when x is 6, y is 11. It's a function. It's just a machine. You put in a quarter, you got a gumball. You put in a quarter, you got a gumball. It's just a machine. Our machine is x plus 5. That's the function. What you put in affects what comes out. It's a function. Once you've done this 4 or 5 times, you can put it on a table. Right? I put in my x's, I got out my y's. I put in a 3 and I got out an 8. I put in a 6 and I got out an 11. Once you have a couple of them on a table, you can graph them, and it'll show you what your function looks like. It'll show you the pattern. Right? So, it's just a function machine, right? Think of it like a machine that takes an x value and outputs a y value, right? This is our gumball machine. Quarter. Don't even judge my little man. You put in a quarter and you get a gumball. This is your gumball machine, right? Think of a function like a machine that takes an x value and produces a y value. It's just a machine, right? The x value is called the independent variable because you pick it. Over here I picked my x value to be 3 and 6. It's independent because I chose it. The x value, or the y value, is called the dependent variable because it depends on what you put in. The x value is independent because it's what you choose. And the y value is dependent because it depends on the x value. Make sense? Alright, so let's look at how to do this using a table. I'm going to go back to doing the evens because obviously that one's going to be harder because fractions. Alright, so let's see what this looks like. Alright, this is our function. We're going to put it in x and then we're going to see what comes out. Let me give myself a little more room to work. I don't know if it'll let me write on that side. I'll figure it out. Alright, so this is our function machine. This is our gumball machine. This is what we're putting into our machine. Our job is to figure out what comes out. Alright, so you literally just work them. I'm going to put it up there like this. You can work it on separate paper, scratch paper, whatever you need to do. Okay? So room to work, y'all. Alright, so this is my function machine. Y equals 3/4 x minus 2. Now I want to know what happens if x is negative 4. So I'm going to put it in there. Y equals 3/4. Instead of x, I'm going to put negative 4 minus 2. These simplify. 4 over 4 is 1. 3 times negative 1. So y is equal to negative 3 minus 2. Right? Because 3 times negative 1 is negative 3. Y is equal to negative 5. Alright? So when x is negative 4, y is negative 5. I'm putting it into the function and seeing what comes out. Let's do it again. Alright, this time we're going to put in 0. Alright, so if x is 0, you should already know that anything times 0 is 0. This is going to cancel. Y is negative 2. If x is 0, y is negative 2. We're just inputting and waiting to see what comes out. That's all the function is. Alright, so y equals 3 over 4. This time x is 4 minus 2. Again, these cancel out and become 1. 3 times 1 is 3. So y equals 3 minus 2. Y equals 1. When x is 4, y is 1. Make sure you're pausing it and thinking about this. I know I'm moving a little fast. Slow it down if you need to. This time x is equal to 8. This simplifies. 4 goes into itself once. It goes into 8 twice. 3 times 2 is 6. So y is equal to 4. When x is 8, y is 4. Alright, let me write this down so I won't forget. Negative 5, negative 2, 1, 4. Alright? I'm going to put them back. Don't worry, don't panic. Negative 5, negative 2, 1, 4. Alright, so now I can graph it. Right? Now that we have this information in the table, we have our input and our output. Now it's an ordered pair. Follow the directions. 4 to the left, 5 down. 1, 2, 3, 4. 1, 2, 3, 4, 5. I wonder if I can erase just part of that. Nope. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 5. I'll just make the important point bigger. 0 left or right, 2 down. 1, 2. 4 right, 1 up. 1, 2, 3, 4. Oh, don't want to do it there. 4 right, 1 up. You sensing a pattern? It makes a beautiful straight line. This is telling us the pattern for that function. 8, 4. It's not going to go that far. 1, 2, 3, 4, 5, 6, 7. Let's call it here. 1, 2, 3, 4. Let's call it here. That's where 8, 4 would be. Now look, if you draw your line, and you know it's a function because it passes the vertical line test. You also know it's a function because there's no repeating x's. So first I input the x values and solved. So I had to solve this equation 4 times. 4 times, because there's 4 values here. I put the answer in the y, the output, and then I graphed it. My 4 points are graphed here, and I connected them with a line that goes all the way through with arrows at the end to tell me that technically it goes on forever. Forever. It's a continuous graph. Isn't it beautiful? All right. Number 4. Another fraction. You're lucky. You don't have to do the ones with fractions. All right, so let's see. Our function is y equals negative 3 over 2x plus 2. We're going to work this same function 4 times, this same equation 4 times. We're just going to change the value of x, and that'll tell us the new value of y. Right? So what if x is negative 2? Negative 3 over 2 times negative 2 plus 2. These two are going to cancel and become negative 1. Negative 3 times negative 1 is positive 3. So y equals 3 plus 2. Y equals 5. So when x is negative 2, y is 5. All right. What about when x is 0? You should already know the answer to this. Anything times 0 is 0. So y is going to have to equal 2. I love zeros. It makes everything so much easier. What if x is 2? Negative 3 over 2 times 2 plus 2. This becomes 1, because any number over itself is 1. Negative 3 times 1. Y is equal to negative 1. So when x is 2, y is negative 1. What about when it's 4? Don't lose the negative sign. It'll change your answer completely. All right, 4 divided by 2 is 2. Negative 3 times 2 is negative 6. Don't lose your y because you need to know what your output. Negative 6 plus 2 is negative 4. So y equals negative 4. All right, so let me write it down. 5, 2, negative 1, negative 4. 5, 2, negative 1, negative 4. Is that right? Okay, now we can graph it. I know I'm erasing my work over there, but you should show your work. Otherwise, how do I know how you got from here to here? And if you make a mistake, where did you make a mistake? When did you make a mistake? How did you make a mistake? How do I tell you how to fix your mistake if you don't show me your work? So if you have to attach a separate piece of paper, then do it. Do it. If you need to write it in your math Bible and you number it so you know what's what and label it with a title, do it. Whatever works for you. Left 2, up 5. 1, 2, 1, 2, 3, 4, 5. No left or right, up 2. 1, 2. 2 right, 1 down. 1, 2, 1. 4 right, 4 down. 1, 2, 3, 4. 1, 2, 3, 4. Oh, I see another pattern. You notice anything interesting? All right, draw your line all the way through your points. Put your arrows on the end so we know that it continues on forever. Now I want to see if you notice something. This one was a positive 3/4 x. The line is in a positive direction. This one was a negative 3/2 x. Your line is in a negative downward direction. Remember that. That'll come in handy later. Oh, look at that. They're going to try and rearrange it and see if they can confuse us. Are we going to let them confuse us? No, we are not. We can either work with it as it is, or we can rearrange it so that it makes sense to us.